neglected from about 68 until the 90s. Now it's coming back.
22 Purdue, Michigan State's got 16, the 3-ball.
In your faded cotton.
Welcome to D-Lab, and today on the bench I have something a little bit different for you guys. It's a Firestone radio that came to me mail order for repair. This is the model 4A12 called the Narrator. What a great name for a radio, huh? Anyway, it came in initially dead because it had a tube filament that had opened. Now the radio plays, but it has hum and the tuning needle stuck. So let me show you what we got going, and hopefully it's an easy repair. So here's a schematic for the Firestone radio. You can see here's where your AC comes in, and there's no power transformer. So this is a hot chassis radio. So what they do is they take that 120 volts and they drop it across these tube filaments, right? So that's why you have a 50L6, couple 12 volt tubes here, and a 19 volt tube here, right? So that drops your 120. Then they rectify it up here with the selenium rectifier. Goes over here through a coil to your filter caps, feeds the high voltage up to the rest of the radio. So if you have a dead radio, first thing you want to look at, of course, are these tube filaments. Because if one of these open, it's kind of like a Christmas tree effect. One light goes out, they all go out. And what's really nice is they have identified the tube pin numbers here. So I'll zoom in a little bit. So you can see like the 12BA6, pins 3 and 4, right? 12AT7, and so on and so forth. So you do not need a tube checker to see which one of the tubes has the open filament. Alright, so for example, this is the 12BA6 that I had to replace in the radio. Here's that original tube, and according to this, pins 3 and 4, which is right there and there, you should see the filament. You can see on my meter, it's open. Alright, so here is the replacement 12BA6, same thing, pins 3 and 4, look at there, you got about 11.5 ohms. So that's how you figure out if one of your tube filaments opened. So now that the new tube is installed, all the tubes light up. Now, let's see what else is going on with the radio. So as you know, it's always a good idea on these old radios, bring them up slowly on a variac. Don't just plug them in, alright? Or you may get a big surprise. So here we are. Here's the insides of the radio. Crank up the old voltage. And she's warming up. If you listen, it's got some static. So that's a good thing. It means it's got high voltage. Now let's go around the front side, see if we can tune in any stations. Here we are front side. I'm still using the variac. And we're on AM band. And it is receiving. Alright, now let's turn the volume all the way down. She's a little stiff. Alright, so we got the volume all the way down now. I'm going to bring the voltage on the variac right up to about 120. There's just a slight hum. Not too bad. Bring your volume up again. Let's go to FM.
With 6 amazing toppings in less than 60 seconds.
So FM's working too.
Sold over 200 franchises, 1,000 robots, and we're officially labeled as one of the
Now one thing I did notice right off the bat, if you look at the tuning needle, the radio's tuning, but the tuning needle is struggling to move. So next step, let's pop the chassis out, see what's going on there, take a look at the filter caps, etc., and see if we spot anything else wrong. So I've got the chassis removed. It's in pretty clean condition. The speaker's not torn. And guess what? Now that it's out of the cabinet, the tuning needle operates fine. So I'm guessing that we have a little bit of an interference fit between the pointer and the dial up front. So maybe it just wasn't installed correctly. I'm not sure. Anyway, let's take a look around the bottom and see what we got going on down there. Alright, little bottom side tour. And you can see she's pretty much all original. I don't see any signs of past maintenance. But take a look at these old paper wax caps. Like that guy down there, he's all bubbling. This one up here, the end is popped right out of him. Alright. This one here looks like he's collided with the solder connection. There's a huge dent in it. There's kind of a hot looking area in the middle of the cap. So yep, every one of these paper caps need to come out immediately. So that's the first thing I'm going to do, is get all those changed. And then right there, this little electrolytic probably goes to the output tube. We'll change him too. So first, I'm going to change all these ugly old cigar butts. Then we'll try to play the radio again and see if it's playing okay. And then I'll check the power supplies. And if we see that that's low and there's any hum, we'll change out the main filter cap. So here we go. So first thing I have to start with, bags of Spragues. So all of these are going to go in there. And all of those are going to go to the dump. Alright, so when you get ready to work on this radio, or any of these old radios, you got to be extremely cautious when you're going to work on the bottom side. Because if you look at this, you've got this cardboard floppy back with the antenna, and then all you have is this rounded edge of the speaker. So if you were to set this guy upside down to work on it, look how shaky and unstable it is. Very bad idea. Alright, so here's what D-Lab does to ensure I do not damage this radio in the process. Is I take one of these beautiful plastic bins, and I'll set that radio very carefully in that bin. Now look how stable it is, okay? And it'll protect everything on the top side of that chassis while I'm in here fooling around, cutting, snipping, and soldering. Good idea, huh? Another tip from D-Lab. Alright, so we're ready to start changing out the caps. Take a look over here. See the end of that one? It's like popped right out. It's amazing. Look at this one here. The end is all bulged. There's a crack. So it's really amazing that these old things, after 60 years in this condition, still operate. Alright? Anyway, we're going to swap them out. Now here is my word of advice. Do them one at a time. Verify the value against the schematic, especially if you cannot read the value on the cap. Alright? You can actually go back, if you wish, right to the terminals and desolder them. But a word of caution, especially like on these IF cans, if you go back here and you overheat that terminal trying to get the cap lead off, it can actually damage the inside of this little transformer and you're hosed. It's all over, right? So my word of advice is clip the cap, clip the lead right next to the caps here and here. Clean those leads with an X-Acto knife, get the wax and contaminants off, make a little hook, and hook in your new caps. I'll show you an example of how to do that. Before we get going on the caps, remember I told you the tuning needle looked like it was hanging up, dragging on the dial glass? Well, take a look here. You see this gap? This whole dial glass over here, it's up against the plastic and then it kind of swoops down. So it appears as though this clip right here is not holding that dial glass up into position. It's actually jammed. The clip is actually on the edge rather than being on the back side. So I'm going to remove this, reposition the glass, or in this case plastic, and that should take care of that issue. So let's start with this cap. He's dead center, easy to see. You can spot the leads there on each end, easy access. This is a 0.05 microfarad at 200 volts. I'm going to replace it with this 0.047 cap that's rated at 400 volts. Okay, 400 volt caps are fine for anything in this radio because the high voltage barely exceeds 100 volts. According to the schematic, it's about 120 volts DC. So 400 volt caps are just fine, and they're less expensive than the 600s, right? So let's just get in here, clip this guy out, get yourself a nice pair of precision cutters to do this. Don't get in there with your big old Craftsman or DeWalt's, you know, and get in there and do the creature feature cut, because you may damage other components, because things are kind of tight in here, alright? So there, the cap's out. You can see our little leads. Take an X-Acto knife, knock off the wax, corrosion, whatever you got going. You can see a little piece of wax there. Okay, clean them up. Otherwise, you're not going to get a good connection. And after you clean these, when you go to put in the new cap, I'd highly recommend that you use a little bit of rosin to also help remove the corrosion. Alright, then you're going to take your your long nose pliers, okay, and you're going to make some little hooks. I'm trying to do this to where you can see, so it kind of it's a little bit difficult, because normally I got my fingers all in there, right? But I want you to be able to see. So we'll take the new cap, we're going to bend him, and we're going to put hooks on each of those leads, right? So hookity-doo-dah, clip him. Okay. You're going to hook him in. You're going to take your long nose pliers and close those little hooks, so you get a good mechanical connection. You're going to do both of those, alright? I'll cut back to it when I get ready to solder, but you get the idea, alright? So then I'm going to hook this one over here too. Okay, the new cap is in place. You see the stud popping up here? You don't want that lead to touch it, alright? So make sure you route your leads away from things so they don't short out and you generate new problems, okay? So I have these mechanically crimped over, like I talked about. Take yourself some good quality solder, like Kester solder. Flow it in there. Set your iron about 700 degrees. And you'll have yourself a great, solid solder connection. So there she is, in place. The old Crustoramus is out. Let's go through and change the rest of them. Like I say, one at a time. Verify the value against the schematic, especially if you can't read it. So I came across a little snag, which has happened to me many times doing this kind of work. This cap here, I've clipped the leads, but I can't get him out, because you got this resistor on top of him. You got an IF can back here, and you got to be super careful not to bust these leads. And there's a terminal board over here in the way. So what's the best way to get it out? Well, you take your wire cutters and you cut him in half, just like a crayon, okay? It's just wax and paper. So whittle this guy in half and take him out in two pieces. Alright, so I've cut him in two. Now you can just take him out in pieces. Makes a little bit of a mess, but it's a lot easier than trying to remove all these other components to get that cap out. There's the pile of caps, including the one I had cut in half. All the new ones are installed. So at this point, I'm going to power the radio up. But first, I'll inspect it under a magnifying glass to make sure that I didn't screw anything up, especially when you get down here by these little coils and things. You don't want leads to be touching where they shouldn't, or all of your efforts will go up in a ball of smoke. Alright, so as before, I'm bringing it up on a variac, and I'm going to watch this current to make sure that I don't have any shorts. So the variac is a good sign. I'll take it right up to about 100 volts. Go over here to the radio. I'm on AM. Bring up the volume.
I mean, the guy emptied out, I don't know what
It's working, however.
And yeah, it was just horrible.
And as we now
I hear the hum. Now take the volume all the way down. There's not much hum there, but then again, we're not really driving the radio at this point, are we? So let's look at the high voltage. Remember I told you it should be around 100 volts. What I'm going to do is unplug from the variac. We'll go direct line voltage. You see, we only got about 80 volts, kind of dropping in, settling in at 80. So that, with the hum I'm hearing, I'm guessing it's time to change that filter cap. First though, is it working on FM? I want to make sure that I didn't induce any problems putting in those caps. Yep. So that's working, but I do hear some distortion in the audio. So let's change out the main filter cap. Right there is the main filter cap. Not too bad to get to. Top side, there's plenty of space, so that's good. How are we looking underneath? We're already down in that area before. There he is. So that's pretty wide open too. Shouldn't be too big of a deal. And what's nice is this is a 4-section cap, but it's only at 150 volts DC. So you can either spend the money and buy like a $30 replacement cap, or you can make your own cap, which is something that I've shown in previous videos, but I'll show you again. Alright, we're back on the schematic. Here is the filter cap. You can see it's a 4-section cap, 40, 20, 20, and 20, and they're all like at 150 volts DC. But to save yourself some money, this last cap right here, if you follow him up, you'll see that it is the cathode resistor for the audio output tube. There's only about 20 volts maybe on that line. So I'm going to strap in a standalone cap here, and then I'm going to change this out with a 3-section cap. So if you were to buy that cap, you'd probably pay about $35 for the metal can type, versus a little more if you had the 4-section, and you really don't need the high voltage on that last leg. So right down there is the audio output tube, the 50L6, and there's a 120 ohm resistor right there going to the cathode. And if you look at that wire right there, he's going over to the section of the filter cap that we are going to eliminate. Okay, so what I'm going to do is remove this output transformer so I can get in here, and I'm going to add the little cap from that 120 ohm resistor to ground. So there's a new little cap in place, making the cathode of the output tube happy. And if we go over here, you can see now that 4th lug on the filter cap is not being used. Next step, we're going to change this out with a new 3-section filter cap. So at this point, you could say, well, I want to put in one of these really nice expensive caps. These are about $40 a piece into my radio. Or you could say, well, how about I build a D-Lab multi-section filter cap using this cheap tube socket and some of these very inexpensive radio caps. Alright, so what we're going to do, this is a very inexpensive tube socket made of some cheap plastic, right? What I'm going to use this for though is a new base for a filter cap. So these lugs that would normally be to solder on for your tube application will now become the lugs for my new filter cap, right? So I just take this guy, put him in a vise, grab a small drill, and I'm going to go right into these holes, and I'm going to drill them out. Right? You get the idea. Then you take your new filter cap, in this case is a 47 at 350 volts, since we know we're not dealing with much more than 100, and you're going to put those in here and solder them underneath. And when you're all done, you can put some heat shrink tube around this to keep everything secure. We're going to pop this thing in like a tube socket, and you're going to wire to the bottom, and it's going to be a nice, efficient filter cap that will last that radio another 50 years. Placement of the new caps on the socket is not really critical. I always try to share commons, so you can see my two negatives there are together, and then there's my main section, the 47. So now I need to go underneath and solder those leads to the terminals. And when you get done, probably be handy to make yourself a little sketch to know that maybe pin 8 is positive and pin 3 and 4 are negative, whatever you come up with. But it's always a good idea to make a sketch so you have a little road map, especially if you're going to put heat shrink on here, because then you can't see the caps anymore. So here's what we ended up with. There's pin 1, 2, 3, 4, all the way around to 8. 8 is my positive 47 microfarad. 5 is a plus 22. 2 is the other 22. My grounds are strapped 3, 4, and 7. Okay, so now I have a little road map. It's time to get the cap installed. Before I install it, I'm going to take this nice self-adhesive heat shrink tube, seat him against that socket. Slinkity-doo-dah! So just like all the other caps, when you change out the filter cap, you should make yourself a sketch so you know what went where, or you can do the quick lead yourself a road map by simply cutting off these terminals down by the filter housing. Okay, cut these off, leaving the wires where they're at. Alright, so then when you bring in the new filter cap, these guys are already going to still be connected to that old terminal, giving you easier reference for connecting the new cap. So I've clipped all the leads. Everything's kind of hanging here in the breeze. So the only thing holding that cap in place now are these little twisty tabs. And you can get in there with a pair of long nose pliers. Just kind of twist them, fatigue them, and they'll pop off after quite a few of these little operations. Anyway, there, he's off. So you do that for all 4 of them, and then that cap will lift right off the chassis. Alright, one note. Sometimes they use the legs of the filter cap to solder other wires to get a ground. And that's what we got going right here. So make sure to get that on your sketch. This resistor here was also connected to one of those grounds. So when I get done, these things will have to be terminated back where they were. So now that those ground lugs are severed off of this can, the cap will pop right off. Okay, so obviously you're not going to be reusing this guy. The next step is to get the new cap in its place. So there may be some slight interference fit. As you can see, this guy doesn't want to seat all the way, so I'm going to have to open this up a little bit, and then I'm going to make 2 holes for these mounting lugs on the socket. Alright, so if you look in here real close, you'll see the interference problem is simply where those little mounting tabs used to be. Other than that, the hole is the right size for the socket. So what I'm going to do is cut those little tabs out of there and make this hole a little more round, and then this guy should drop right in. So there's a couple ways you could open that hole. I guess you could grind it. You could take a Dremel tool and slice and dice, or you can use one of these nice little chassis punches, which is what I'm going to use. If you look underneath, she'll clear, so you just got to be careful. Pop him on through, and then the new socket will drop in. Luckily, there's all kinds of room to get your wrench in here and operate the chassis punch. Now if you had a socket, that would even make this go smoother. But these punches go through that metal like butter. Punch did its job. The hole's open. The new caps can drop right in. Alright, next thing we need to do is make the holes to mount this little socket. So it's going to go something like that. Reach underneath. Make sure nothing's in your way when you drill. So we'll pop him in here. Make sure it's centered. Give us some little index marks. And get it drilled. So there it is. Holes are drilled, ready to mount this guy. So I'm going to use some 440 screws and lock nuts. There's a new cap assembly installed. Here's my grounds. I added a ground lug right here to tie that to, and to tie these little stragglers to that used to be connected to the base of the old filter cap. There's the new cap in place. Go underside, check out the wiring. There he is. Actually, it doesn't look too bad, does it? And it saved you a lot of money over one of those stock metal type filter caps. Getting ready to fire the radio back up. We're back on the Variac, and I've got my voltmeter monitoring that high voltage. Now you might think that that was a lot of work to save a few dollars, in this case probably about $40 on a filter capacitor, but that's not what this video is about. This video is about to show you the technique in case you would like to do this. Not about being a cheapskate. Here we go. Back on the Variac. Monitor my current. I got about 50 volts applied. You can see we got about 60 volts on the meter. I'm not seeing any strange current jumps, so I'm assuming that the new power supply is working fine. I'm going to take it back up to 100 volts. You can see we're already jumped up to about 122. We never saw voltage that high before with the old filter cap. So she's a little more healthy. Let's bring the radio up. There she is.
I wish I didn't get so weak.
So she's working well. Good deal. So as you can see, even after it's pulling current and settling down, we're a little over 100 volts, and that's what the schematic showed. It did not show 80 volts like we had before. So the old filter cap was leaky, and the new one's not. So you gotta love the little Christmas tree light that they used to light the dial up. That's pretty classic, huh? Anyway, the Firestone is alive and well. New caps are installed, and it's playing. Next, I need to go through the tubes and do some other things, but that's where this video is going to end, because the intent of this video was to show you techniques for changing coupling caps and filter caps in these old radios. It doesn't necessarily have to be this Firestone. They're all pretty much the same. You open them up and you see those old nasty caps. Guess what? It's time to change them. You don't even have to check them. Just change them, and then you'll have a great working radio again. I hope you enjoyed the video. We'll see you again. D-Lab.
Back on